start stream start. It goes with just that one. Okay. EDC, no. I don't know what's going on. Just this is the what's it file. No. Take this one right. The what's it file is correct. No. You just take the 335G. This one use the 0.38. This final 604. Oi. All right. Yeah. In order. Okay. I treat lesson in what else the speaker. The speaker we use that one in the input. Sure MV. Okay. All right. This one we didn't open it. All right. Yeah. All right. So good afternoon, everybody. Welcome you to SCI33. I may have to use the speaker, right? Where is that? Oh, ternyata banyak. Okay. All right. I hope that the voice is fine. takes a look. Let's take a look at Apple Watch. Okay, it's fine. Yeah. Yes. ที่สูงนะครับ Okay. And this one ครับ no wait. Let me record it. โอเคธนรัตน์มาแล้วนะครับ and Mr. Stellung in yes, this in we live stream to YouTube, right? Use this one. Zoom to YouTube. All right. ไปแล้วนะครับไม่ทราบว่าคุณได้ยินหรือเปล่านะครับครับเพียรalright next เสียงไปแล้วนะครับ alright everything is fine and we get back to Zoom finish this and make the screen sharing yes นั่นแหละครับเหมือนกับกันพลนะครับกันพลที่โอเคครับบิวเชื่อมไมโครโฟนโอ้โมเมนต์บิวเชื่อม starten โอเคโอ้ไม่ทราบว่าเสียงไปหรือเปล่าครับ let me check whether fatal start fortfahren in yes we arrive at the Gaminometer, right, for M604 right here as we have said before, it is the induced force, okay, due to the coil in let me monitor it first. What happened? Untitled. Oh no. Alright. I mean here we have to monitor you at this location and join soon with this one, right? Yes, this is the Zoom version, right? ที่YouTube ที่มาจาก Zoom นะครับมีกสิดิตนะครับกสิดิต1 คนครับ and I'm not sure the one directly from the computer will work well or not. Oh, all right. All right, here yeah, this is the Gaminometer, right? Gaminometer can be used as either พาวินมาเดี๋ยวรอสักทีหนึ่งก่อนก็ได้โอ้เนอะ การพลย้ายที่ YouTube ได้ครับคุณ พิมพ์ที่กันพลผมเห็นละเข้ามาที่พิมพ์ที่แชทใน Zoom นะครับตามสบายเลยครับมันมี2ช่องนะครับมันมี2ช่องนะ YouTube นะครับตรงที่ Zoom นะครับผมที่ Zoom เนี่ยผมขึ้น resolution นะครับเป็น high นะครับผมไม่รู้ว่าได้ 1,000 หรือเปล่านะครับมีคน2 คน alright เนาะแล้วก็ไม่รู้ตอนสตรีมตอนที่ forward ไปที่ YouTube นะครับจะชัดมากเหมือนกันหรือเปล่านะครับไม่ทราบนะครับ but yeah เดี๋ยวนะครับปิดไมค์โอเค alright yeah yeah, I'm not sure but the screen seems to not so sharp copy link yes Gaminometer is used มีอะไรแดงๆมาเลยแชทใช่ปะในแชทมีคุณมาด้วยนะครับalright Gaminometer can be used either ammeter right or the ที่นี้นะครับมีพิสุทธิ์มีอะไรอย่างนี้นะครับเดี๋ยวผมขออนุญาตแคปเจอร์หน้าจอไว้ก่อนนะครับ alright and this one moment we didn't get the monitor yet I'm not sure which one is correct yeah ไปไหมเอ่ยไปไหมครับหน้าจอยังไม่ไปที่ YouTube กันนู้นนะครับคุณอยู่กันก็ไม่บอกนะว่าจอไม่ขึ้นคุณพิมพ์ชื่อกันรวดเลยนะครับwhat's the problem ไม่รู้ว่าต้องalright ก็ยังไม่ไปที่ YouTube ช่องนั้นครับหน้าจอยังไม่ไปนะครับทำไงดีนี่ครับ this one yes thumbs down but I'm not sure the voice is work fine or not in Zoom ได้ยินเสียงชัดเจนไหมครับ Zoom ครับ Zoom ได้ยินเสียงชัดเจนไหมเอ่ยครับเสียงนี้นะครับ I'm not sure whether you can hear me well in Zoom or not but anyway ที่ Zoom นะเดี๋ยวดูแชทที่ Zoom แป๊บหนึ่งครับมีปองพลมีธนนัทนะครับ2 คนครับ so we go up Zoom นะครับช่อง YouTube Zoom เองก็ตามครับไม่ทราบว่าเสียงมาถูกต้องไหมเอ่ยเพราะว่าผมเปลี่ยนตัวรับเขานะครับ alright I hope that everything is fine in yes Gaminometer is the historical name of an instrument, okay, for measuring a small electric current, okay, small amount, okay. We would not use because that's the early generation for the measurement device that the human has set up. And yeah, it uses the notion you have learned the solenoid, right? The solenoid is the coil with several turns, right? It's a number of turns, right? In yeah. This one. All right. And yeah, the most common type is the so-called the Songwan, okay, the Songwan galvanometer, okay. I think this is the French name, okay, from the from he would be from France. In when there is a current in the coil, the magnetic field exerts a torque on the coil, okay, and the torque is proportional to the current. So if you know how much the current flows, you can get the torque from that, right? And how much torque happen will bring the needle, okay, the needle on the monitor of the galvanometer to rotate, okay, and that's the idea. Yeah, we would consider the angle, okay, angle of rotation or angle deflection in yes, the angle of the deflection should depend on the torque, okay, that again come from the amount of current that you put into that galvanometer. All right. Okay, here we will consider first the first application, okay, for the galvanometer, and it's called ammeter, right? Ammeter is the device used to measure the current, okay, which is quite straightforward according to the Bian formula, right? BIAN, Bian psi phi or psi theta, right? It's quite straightforward. คำว่ามีพิมพ์มาที่พิมพ์มาที่ไลน์นะครับเดี๋ยวดูที่ไลน์นี่เลยกิตติพันธ์เรียน YouTube นะครับที่ซูมนะครับอันนี้เคนะครับเคกับสิริกันพล YouTube เอาผมเข้าซูมหน่อยครับขุนมีอีกไหมเอ่ยหมดแล้วนะครับโอเคนะครับขุนเข้ามาแล้วนะครับแล้วก็อัครวัตร17เอาอัครวัตรอยู่ที่นี่โอเค anyway we go ahead with the instrument that measure the current, okay, is of course called galvanometer. All right. In the essential concept of the ammeter is that okay, you should know the idea of the galvanometer. Okay, galvanometer should okay, sorry, the ammeter is used to measure the current, right? So in ideal case the theoretical ammeter the meter should have zero resistance. okay, should has no resistance at all. Okay, the resistance should be 0. Okay, it means the internal resistance in the ammeter here. This is the ammeter. R should be the resistance of this ammeter. R of ammeter should be close to 0, or it would be perfect if we have 0 ohm for the internal resistance of the ammeter. And ideal ammeter should have 0 resistance, and so that it doesn't obstruct the current at all. Okay, it has no impedance to the flow of the charge or the coil, okay, or the current, okay, in that branch. Gaminometer can be made into an ammeter. Okay, we can you have G, right? You have G. It can be used as first thing here in this section, the ammeter, and the second one is voltmeter. Okay, the notation of the ammeter is denoted by A with the circle around that. All right, in the next thing, the second thing is voltmeter. Okay, voltmeter is used to measure the voltmeter is used to measure the volt. Okay, the potential difference between 2 points at any 2 location in the circuit. Okay, as you want to see, wherever you want to see the potential in the circuit, so you can use the voltmeter. Okay, we will talk about that later. Yeah, and now we arrive at the first example. Okay, it's better to see. Okay, this one is quite difficult. Okay, because it really goes into the detail of the circuit analysis. In I don't know whether this topic is included in the typical high school level. Anyway, let's do that. Now we consider this branch. All right, this one. In this example, okay, in this problem, let R, the capital R, be a small resistance. Okay, for scaling the galvanometer, and it has the galvanometer has an internal resistance, which is denoted by the small letter R. Okay, small r here, and to support a full scale current. Okay, the maximum current that this galvanometer can measure is called full scale current. Okay, that's the maximum value for the current that this galvanometer allows. Okay, to go in through it. In okay, we cannot measure the current beyond this value. Okay, the full scale current, and yeah, that's the basic information. Okay, we have two things. Okay, the first one is the small resistor, which is denoted by R, and our main interest is the galvanometer. Okay, is the galvanometer, which is denoted by G. Okay, but G right now is used as ammeter. Okay, and inside this galvanometer we have an internal resistance, which is denoted by R. All right. Okay, and R should be quite larger than small r. Okay, because they use the capital version. And yeah, that's it. We move to the next thing. Like this. What is the value of R if we want to use a 25 ohm galvanometer. So what is that? The information they have provided here is this is the internal internal resistance, okay, which is the green one there, okay, the green one here, okay, this one, and with 50 microampere sensitivity. So what does this mean? It means it represents this one, okay. 50 microampere is the amount of the full scale current, okay. This is the maximum current that you can use the galvanometer or ammeter to measure, okay. It cannot measure the current above this beyond this value. And to measure a full scale deflection of 1 ampere, oh my god, what is that? So the range that we can measure the current is 1 ampere, okay, but this galvanometer can allow you to can allow the current, okay, to flow with 50 microampere only. So how could we do that? Okay, we have the device, okay, that can support only 50 microampere. So what is that? 50 microampere. 50 microampere means it's 50 times 10 raised to 6, right? And ampere, right? It's very tiny. Okay, this galvanometer is very sensitive, and that's why they say galvanometer is used to measure only small amounts of current. Okay, you cannot use it to measure a large amount of current. But we will scale somehow in order to be able to measure the full scale current of 1 ampere. Okay, this is the full scale deflection, okay. That's our target, okay, the desired value of the current. How could we connect the two things together? Should we connect both things in series connection? What is that? Series connection or second parallel connection. Which connection should we use to measure? To connect those two steps together? What do you think then? In order to measure the current, okay, by using galvanometer. No, I should use the G. Okay, we have to use G instead of that because the raw material is galvanometer. Okay, we use G instead of A. All right, and yeah, that's the target we would like to know right now. Yeah, the way to do that is where they didn't provide. We have to use the so-called parallel connection. Okay, we have to use these two things. I'm not sure where is the figure. Maybe it's collapsed somehow. Figure 61. And the next figure is 52. Okay, 52 is here. Okay, in order to measure the current, okay, by using the galvanometer, you should connect any resistance with the galvanometer in parallel way. Okay, this is the parallel connection between the galvanometer and resistance. Okay, they just draw the internal resistance, okay, separately, the internal resistance of the galvanometer separately from the actual module of the galvanometer. Okay, this is the module, the block of the galvanometer. Okay, this device is used to measure the current perfectly, but unfortunately, when we have the copper inside the galvanometer, there should be also the internal resistor ครับสำหรับคนที่อยากให้เหมือน605มั้ง request บอกว่าให้ผมอธิบายภาษาไทยด้วยนะครับ ก็คือตอนนี้เราเรียนเรื่องการมานอมิเตอร์นะครับการมานอมิเตอร์เป็นเครื่องมือโบราณที่ผมอินโทรแนะนำคุณไปแล้วนะครับ ก็การมานอมิเตอร์นะครับสามารถใช้ไปใน2ทางนะครับก็คือใช้เป็นตัว A ก็คือแอมมิเตอร์ใช้วัดกระแสนะครับแล้วก็ตัว B นะครับใช้เป็นโวลต์มิเตอร์นะครับแต่ในความเป็นจริงนะครับการมานอมิเตอร์เองเขาก็จะสร้างมาจากขดลวดนะคุณเห็นนะครับเห็นไหมสีชมพูนี่ก็คือขดลวดนะครับตรงนี้ก็จะมีคอยเห็นไหมครับไอ้พวกคอยโซลินอยด์อะไรพวกนี้นะครับข้างในนี้จะมีลวดทองแดงอยู่นะครับพวกคอยโซลินอยด์มันก็ทำจากเมทัลนะครับพวกคอปเปอร์ทองแดงนะครับมันก็จะมีความต้านทานอยู่นะครับจะบอกว่าแอมมิเตอร์ข้างในเนี่ยมีความต้านทานเป็นศูนย์เลยมันก็ไม่ถูกนะโอเคไหมแต่ว่าทางอุดมคติแล้วมันควรมีความต้านทานเป็นศูนย์ครับแต่ในทางปฏิบัติเวลาสร้างจริงมันไม่ศูนย์นะโอเคไหมครับโลกความเป็นจริงจะต่างจากทฤษฎีอยู่บ้างนะครับแต่ว่าก็ไม่เกินฝีมือมนุษย์นะครับเมื่อเราจะดันทุลังใช้การมิโนมิเตอร์มาวัดกระแสนะครับเป็นฟังก์ชันเป็นแอมแพร์แอมมิเตอร์ตรงนี้นะครับโอเค we're gonna use the galvanometer to measure the currents. Okay, and we have to connect both galvanometer and as resistance, a resistor. Okay, in this way. Okay, which is the parallel connection. Okay, all right, and yeah. What else? The next thing. ที่ซูมเสียงใช้ได้นะครับโอเคไหมเสียงใช้ได้นะ and what else ไม่จบเลยหรือว่าอะไรมันไม่ไลฟ์แล้วอันนี้ alright in yeah yeah you can see the mechanism of this connection. Okay, the parallel connection between connection of both the resistance and the galvanometer. Okay, this is the I total. Okay, the total amount of the current. Okay, flowing through. This is the whole box of your ammeter. Okay, this area. Okay, now your ammeter include this area. Okay, the whole area here is the part of the so-called ammeter. Okay, and galvanometer just locates here. Okay, at the upper branch. Okay, at the upper line here, and a resistor locates at the lower position. Okay, in order to scale. Okay, the whole the ability of the galvanometer to accept or to cope with larger amounts of current, okay, to be measured. All right, in order to make the analysis of this one, okay, one thing you have to know is that whether you measure the voltage across the upper branch นะครับคำว่า branch นะครับในภาษาวงจรนะครับเขาเรียกว่ากิ่งนะครับโอเคไหมกิ่งข้างบนครับส่วนคำว่าโนดนะครับก็คือจุดโอเคไหมจุดยังไม่เจอโนดนะครับตรงนี้มันก็เจอโนดอยู่ดีโอเค in the upper branch we have a voltage of a certain value and in the lower branch we should have the same amount or the same value of the voltage. Okay, because this point has the same node as this one. Okay, this point and this point are the same. Okay, and this point and the lower point are the same. Okay, because there is no resistance or any device during this journey, during this route at all. Okay, the voltage across the upper branch should be equal to the voltage at the lower branch. All right, and that's the idea. We will use it to make the calculation. Okay, what they want to know is what is the small resistor R. Okay, what is the value of R? This one. What should R be in this scenario? All right, and yeah, that's it. The case that we have to talk about. All right, in yeah. And as you know, the voltage here is denoted by from the Ohm's law, right? VIR, right? So at the upper part, you have okay. The current can be separated into two things. Okay, the upper one is I galvanometer. Okay, let's say the I passing through the upper branch is denoted by the subscript G. Okay, the capital G, which stands for galvanometer, and the lower one is denoted by simply capital I, okay, which is the representation of the current, right? But we don't need to say any subscript at all, okay, for simplicity. And of course, the current that is separated to the above direction and to the lower direction, and finally it combines, both combine to each other at another side. And of course, you can see here that there are two relations. Okay, the first one is the voltage across the upper and the lower branch are the same, which means if you apply the Ohm's law, okay, the Ohm's law. So Ig, right, I galvanometer times R, which is the internal resistance of the galvanometer, equal to the current in the lower branch. Okay, current in the lower branch times the resistor in the lower branch. Okay, and that's the first equation. And in the second equation, the relation is the following. Okay, you have here the current flow in this direction, and another one to the upper part, and one part to the upper part, and another one to the lower one. Here is Ig, and here is I, right? And from this point, you can see that there is the relation, right? I should not write down here. I total, they use TOT, okay. I total should be the summation of these two things, right? It goes this way, okay, away from this point or this node. The current below just go away from this point too, all right? And so it means that I total should be the combination of these two currents. So in mathematics, we would say Ig plus I, right? So we have two equations, the first equation, the second equation, and let's get into our target. They would like to know R, right? What is the value of R here? And small r is the internal resistance of the galvanometer. They said internal resistance of the galvanometer is 25 ohm, right? In the what else? Yeah, the information, we write down information, okay, in order to solve this. The capital R is what we would like to know, and internal resistance of the galvanometer is 25 ohm. Okay, R is 25, small r, right? Small r is 25 ohm, and the sensitivity means Ig. Okay, when they say sensitivity here, sensitivity of 50 microampere. Okay, all right, here it means it's Ig. Okay, that's equal to the value of Ig. I with capital G. Okay, that's the maximum ability of the Gaminometer to accept the current. Okay, so it's 50 times 10 raised to negative 6 in microampere, right? 10, oh no, it's 1420, right? So 14, we still have 40 minutes left. The next thing is that they want this ammeter to be able to measure the current of, what is that, 1 ampere. So the current here should be 1 ampere, okay, not this value, okay, not this one, okay, or not this one, okay. IG is not 1 ampere, okay. IG is the maximum allowable ability of the Gaminometer to accept the current, okay. It's not that, it's only 50 microampere, but the total current that the whole structure here should accept the current should be 1 ampere. So I total is 1 ampere, right? So now what we have is there are 1, 2, 3, 4 variables, right? And 5 variables, but with 2 equations. So let's substitute everything into the first equation. Ig is 50 at 10 raised to negative 6, right? 50 times 10 raised to negative 6, and times R, right? R is the value of the internal resistance, which is 25, and equal the right hand side. Ig is there, I total is 1, right? But we would like to know Ig is known, I total is what we don't know yet. And yeah, we will substitute everything into this one. All right, and I total is number 1. All right, and Ig is the maximum allowable capability of the galvanometer, which is 50 microampere, right? 10 to negative 6, and time, oh no, not times, plus I, right? I is the current in the lower branch, okay, that passes the additional resistor, the capital R, right? So in this case, you know already what is the value of I, right? So if you solve this equation, okay, just move 50 times 10 to the negative 6 to the left hand side, you would get the value of the current in the lower branch, and it's going to be 1 minus 50 times 10 raised to negative 6, okay, and that's the unit in ampere, right? That's the current in the lower branch. Now we get to know the value of the current below. All right, so that would be sufficient in order to go ahead with equation number 1 on the right hand side, okay. I is that value, okay, which is quite long. It's ผมไม่น่าเขียนชิดเลยนะครับ right, left hand side IG is 50 IG เหมือน Instagram time 10 raised to negative 6 and R is 25 ohm, right? It's 25 equals the small I, capital I, without any subscript. It's 1 minus 50 times 10 raised to negative 6, and times R. All right. Oh, R is what we don't know and we would like to know, right? In yeah, leave the R here. All right, and you move this part, all right, to the left hand side. You will get the value for the R, right? Which is right now 25, right? And 50 10 raised to negative 6, okay, and divided by 1 minus 50 times 10 raised to negative 6. All right, and you just leave it into the calculator. I'm not sure whether it's a nice number or not. Yeah. I'm not sure whether it's a beautiful number or not. Alright yeah นะครับคุณก็มีอะไรเกิดขึ้นที่สูงอะไรไม่รู้ครับalright yeah you just use the any calculator in order to see it this one right yeah right 25 times 50 times 10 let's just do a negative 6 right and divided by 1 minus 50 times 10 to the negative 6 again. All right there, and you save it and you generate the result. All right, I hope everything is fine. Oh yeah, that's the answer. 0s 2 zeros 1 2 5 0 1, right? It's equal to what is that 0.00 12501 12501. Okay, all right, and the unit of no, the unit of this resistor is in ohm. Okay, so you should find any resistor of this value. Okay, which is, what is that? If we write it perfectly, it's equal to what is that? It's equal to 1.2501 milliohm, right? Milliohm, because it's the multiplication with 10 raised to negative 3, right? If we move the full stop or the point here 3 times, okay, it's going to appear here, right? It's 1.2501, and it's milli because it's 10 raised to negative 3. So you should find any resistor of this value, and the problem is that there would not be exactly 1.2501 ohm, okay, for the resistor that you can find on the market. Okay, so we should use the approximate value only, okay, which is 1.05, okay, milliohm. All right, and I hope that you would get the idea, okay, how to apply the Gaminometer to be used as the ammeter. Okay, the ammeter is used to measure the current. Okay, when the current flow here, part of it is flown in the lower branch, part of it is flown in the upper branch, like that. In okay, this branch, okay, this resistor is included in order to support, okay, a partial amount, okay, an amount of the current apart from the actual current, okay, and yeah, and when the current flow maximally, the Ig should be the maximum value, and the needle in the Gaminometer should stay at the maximum point. Okay, that's the full scale value of the Gaminometer. Okay, if you let the current flow a little bit, okay, but not of the maximum value, the needle of the Gaminometer is going to point somewhere there. All right, okay, it's not on the full scale, okay, but when we reach the 1 ampere, okay, at the total branch here, the needle in the Gaminometer is going to point in the full scale, but actually the current flow in this branch is only 5 50 microampere only alright นะพอเข้าใจนะครับว่าใช้การมานอมิเตอร์มาแปลงเป็นวัดกระแสนะครับแปลงเป็นแอมมิเตอร์นะครับใช้ยังไงนะครับจับมาต่อขนาดกันโอ้ sorry sorry for that ขออภัยครับจามนะครับalright I hope everything is right now we go ahead with the next application of the Gaminometer นะครับคุณก็จะเห็นประโยชน์มากนะที่เรียนครับใส่ทำไม alright yes we go to the next page which is another application of the Gaminometer okay as I told you before the Gaminometer can be used either as either ammeter or voltmeter now we will consider this one okay the voltmeter okay you know that voltmeter is used to as the name suggested voltmeter is used to measure the voltage okay for example if you have this is the end flow there is a current flow like this okay that should be voltage and you connect the voltmeter to this one okay let me summarize something to you okay ammeter is used to if you want to use the ammeter you should connect it in series way okay and the voltmeter should be connected in parallel way all right yeah you should connect it in parallel way okay and you may say here is the parallel connection no I mean this is the whole ammeter okay this is the whole ammeter and in this area it's the whole green that area here okay is called ammeter okay you just move the whole stuff here okay to points here to be any point in the circuit but you have to connect it in a series way okay for example if you want to see the current in this branch you have to use the scissor okay to cut this point okay to cut it for example here if you want to see the current flowing in this branch if you want to know IA for example right here you have to use the scissor to cut the conductor here at this point okay we open this circuit and you just pick up two things two nodes here to be at this location and you will get the ampere the ammeter inside into this branch okay all right a green one okay you would have ammeter okay the whole structure there all right yeah the ammeter is the green area okay? Is everything in this green area you have to connect it in the series connection to any branch okay but in order to measure the voltage you have to connect the voltmeter in parallel way okay this is the parallel way of connection parallel connection because you leave two nodes okay you didn't cut the branch at all okay unlike this one unlike this way you cut the branch and you just insert the ammeter into that branch okay that line it means it's the series connection but in this way you didn't cut anything okay you didn't disturb the branch at all you just connect or add two additional points to the whole branch okay across this area the area that you would like to see the voltage okay let's say this is IB okay and let's say this is RC okay so the value of the voltage that we should be able to observe in this voltmeter should be the product between IB and RC okay the value between IB and RC should be observed on the monitor of this voltmeter นะครับไม่รู้ว่าคุณจะได้มีโอกาสทำแลบบ้างไหมนะแล้วก็จะได้สนุกนะครับแล้วก็จะพบว่ามันไม่ตรงตามทฤษฎีบ้างอะไรอย่างนี้นะครับเราก็ต้องมันขึ้นกับหลายอย่างนะครับบางทีนะครับตัวต้านทานเนี่ยก็ซื้อมาคุณภาพไม่ใช่ขอบทองเป็นขอบเงินอย่างเงี้ยมันก็จะมีความเออร์เลอร์ใช่ไหมหรือว่ายิ่งแย่กว่าเงินไปเลยนะครับความกวัดแกว่งของค่านะครับคือมันจะมีโรงงานผลิตมามันจะไม่ได้ค่าเป๊ะๆนะครับมันเช่น 12K มันจะไม่ได้12มันอาจจะไม่ใช่ 12,000 โอห์มเป๊ะๆมันอาจจะเป็น 12,000 แล้วก็มี5โอห์มแถมเข้ามาตรงท้ายอย่างเงี้ยมันก็จะมีบวกลบความผิดพลาดนะครับเนื่องจากโรงงานผลิตเงี้ยก็จะมีความผิดพลาดตรงนั้นนะครับแล้วก็ V ที่โวลต์มิเตอร์กระดิกอาจจะไม่เท่ากับ IB คูณ RC เป๊ะนะครับเพราะว่ามันขึ้นกับ R ที่โรงงานผลิตมาด้วยหรือว่ามันขึ้นจากความเออร์เลอร์ของตัวโวลต์มิเตอร์ด้วยนะครับก็ปวดหัวกันไปโอเคไหมครับเวลาทำแลบว่าเราต้องวัดค่าให้มันตรงตามทฤษฎีนะครับก็ได้ตรงบ้างไม่ตรงบ้างโอเคครับสมัยผมอยู่ปริญญาตรีนะครับ alright yeah that's the story that you may face with if you study electrical engineering in the faculty of engineering alright voltmeter alright yeah that would be the complement right as you can see here in order to accept more current we use Gaminometer okay to be connected in parallel way to an additional resistor which is the capital R and that's the quantity we have just determined or calculated right and in this one voltmeter we'll use a different way okay we are gonna connect an additional resistance okay it's not small here is say is stated as a large resistance okay in a series way okay what is that 63 here okay here voltmeter is the whole string can be decomposed into these two devices okay this is the first device this is the additional resistor okay as we have seen in previous example and here is the Gaminometer and you may ask me why they write down a resistor in front of the Gaminometer okay this is the ideal case of the Gaminometer it has no internal resistance at all okay but in fact in nature in practice we could not do it we cannot make it if you can make it but you have to use this device at the the temperature of minus 40 degrees of Celsius is impractical right because we should work in the room temperature 25 degrees of Celsius and so on so that's why they write down an additional resistor in front of the Gaminometer this is the theoretical or the ideal Gaminometer and this is the internal this symbol represents the internal resistance of the Gaminometer okay inside the Gaminometer because the Gaminometer has also a solenoid right you have seen in the previous class we were dealing with we deal with the solenoid right and solenoid is made of copper so there should be also there should be some thing from the there should be some resistance from the imperfect conductor alright that's the way we modify okay this is a piece of Gaminometer okay let's say this I write that